Streaming. I think we're streaming. Okay. All right. So, hi, folks. I'm here at the Notion Theory office today, and I've got Twitch running in the background. That needs to stop right now. And so, yes, I'm Sean Macbeth. I'm the lead VR engineer here at Notion Theory, and today I'm working on, well, it's up there somewhere. Yes, this one right here. Primrose. Primrose is our WebVR framework for being able to make virtual reality applications in your browser, very quickly put them together, and walk around in them with your HTC Vive or your Google Cardboard, anything in between. So today I'm working on fixing some defects because software has defects. Yeah. And I'm working on getting multiple pointers working so that you have your mouse or your HTC Vive hand controller and you can point at things and you can say, hey, I click you, Pikachu. So without further ado, let's go over to some code. There we go. So I'm on an ultra-wide monitor today. Well, not literally. It's just much larger than I'm used to. But we got a lot of code here to go through. To see what is going on right now, I've got these disks. These disks represent where you would teleport to if you would click there, and both of the disks are showing up at the same time, and they should not be. And also, there's no pointer here activating on the monitor, and no null pointer indicating where we're looking. So we're trying to figure out where this is going to go to fix everything. Okay, I can minimize this down. I don't need this window. All right. First things first, let's try to figure out where that regular pointer went. To do that, I'm going to stop the hit testing from running. Where that runs, I can remember here. I'm just going to turn that off that way. Oh, here. Pointer exists, that's correct. It's in the right orientation, it's pointing in the right direction. The question then becomes whether or not the math for projecting it onto an object is correct. Going to change this to this logging output. Simplify it down a little bit so I can only see one particular output object. Just want to see the mouse. Come back. Something. Paren. Okay, so mouse. It looks like we are starting from point 3.3 in the Y direction. That makes no sense. That is way too high. We half that. Apparently believes that we are twice as tall as we should be. and it is going to point ahead, which looks like it is correct. The correct point ahead. So the point to begin at is correct. The point to end at is correct. That's odd. Find out why that happens. This is update function. Here. It's here. The position of that particular object. So the issue is we put the end of the pointer on the ground and it's actually popping up. That is happening at this point here. This is translating the object up into the air. So why? So that's okay for the forward, but the pointer itself should not be up in the air already. Where do I do that? It's not here. Is it here? Update position. This will be in mouse. No, it's not an update position. Update velocity. So we have a start position. I set it right there. So I'm setting the height of the object here, and then it is getting translated again. Interesting. So why are they not just 0? Set this to 0. That puts us in the ground. It makes the first vector correct, not the second one. That's not correct. Set player height function. So the issue here is that with various headsets, such as the HT5, they report an absolute position within the space in which you're working. So if you're sitting, or if you're sitting in a chair, they tell the software developer that you are standing a meter above the ground, and if you're standing, they tell you you're standing 1 2/3 meters above the ground. But the Google Cardboard and the Oculus Rift do not tell you such a thing. The Google Cardboard has no sense of how high you are off the ground, and the Oculus Rift gives you only a relative position based off of where the sensor imagines is the 0 point. So in order to handle this, I have a project called WebVR Bootstrapper, which is meant to sort of normalize some of the interfaces between different WebVR compliant devices. And in the case where we do not have an absolute position, it attempts to assume a position, a height. Where did I put that one? There. No, this is not. Where did I put that? Here is where I read the stage parameters for a display. Where do I set the stage parameters? Let's see, so the process. Avatar height set. This class. There. That's where it's called. It's an option. It's set right there. So as this is where the default value is set, and then it gets passed through various machinations to get to here, so that when our WebVR display device does not provide us stage parameters, we create a fake value so that we can normalize between the two types of devices. HTC Vive gives us this sitting to standing transform, and everything else that does not. This is fine. This needs to stay this way. Question is, where does this value get incorporated? Do any reading of stage here. This is where we read the stage, and then this is where we set it. See. Well, since it's so specific, we don't actually need this value. It's kind of a bad sort of practice. Anyway, since we only need it in the one call, put it there. It's unrelated to our problem, but it's nice to fix things as we go. I'll update here. Which is just aggregating the return values. sense. Or, no, actually, it makes no sense. Should be. There. Be a little faster. Sense in doing things poorly. This is an issue for later. But again, it's unrelated to what we're currently working on. Okay. At this point, we have for position. Have correct. We have the position is up in the air. That is pre-transform. Pre-transform, it is up above where it's not supposed to be. Let's look at put or vehicle or player. Anything position. Okay. Vehicle, setting the position. Move. Set the player height. Now after the fact, I want to read it in. So we start on the ground and we end in the air like we're supposed to, but for some reason we are rendering in the ground. So that means compare. This. Printf debugging is wonderful. Okay. So our vehicle is in the air, our player is in the air on top of that, and then our camera is not offset. That is not correct. That was not the end of our processing. All on the ground. Look at that. All on the ground. Well, the vehicle actually needs to be up in the air. That is technically correct. Let's reload. Okay, so that is correct. And then the player is on top of the vehicle and the camera is on top of the player. Because actually the vehicle is what moves around. The player does the player's movement is the movement of the VR headset. So this is fine. Now, so this means that Mesopotamia. Let's see if that actually ever happens. No, it doesn't actually happen. Oh wait, save it. Doesn't ever actually happen. Okay. That simplifies a little things a little. Let's put the player height in the individual input processor, and instead of offsetting the object directly, we're just going to set the player height there. We will only need to set it once. So this will be incorrect on the first run through, but it will work out for us in the end, I believe. Can't read size x of undefined. That is at point. Well, I thought you told me that we always have a stage. Oh, we just flew away. Interesting. Oh, because I'm not. I set that value, but then I never used it. Okay. Still flying away. Okay. We're on the ground. We're flying away. Broken it. Once again. But this might be a different issue. So we're going to leave it momentarily. All right. Okay. Good. Far so good. What are the values we should see? Okay. Seems correct. So now that. Oh wait, back to that. This had its own avatar height property. I see. This could be a problem later. Yes. Call it a different. Next thing to do is to turn projecting back on. Check the segments. Check the segments. This will be printing let's just see what it does. Not a number. I think that was just a temporary. Because it was updated. Mouse. Okay. All right, we've got a pointer in the right position now. Even though we're flying, we shouldn't be flying. The pointer is at least in the right position. Let's turn the projector back on. Ha! Things look correcter. Look at that. We've got a pointer pointing in the right direction. Let's turn off that printing now. Okay. And why aren't so we jumped? They're through the ground. Ah, interesting. Okay. So we moved the player. Why is there no gravity? Gravity should apply to the vehicle. Z, rocket off, but if I hit Z again, strange. Anyway, looking for where the vehicle's position gets set. That's not correct. It should not be. Let me see. Okay. It should be. Oh. Okay. That's correct. Oh, we're still not quite correct there. We did manage to click on the thing, but it did not activate full screen mode correctly. Now we can't activate full screen mode at all. Oh, there we go. Oops. It just plain doesn't like it. Okay. Do we ever use gravity? We have gravity there. We never use the gravity. Well, that's why we fly. Move player. This is where it would be. Okay. So... Let's see if that makes us fall. No, it does not. Flying up in the air, and our velocity is not constant. It is not remaining. Even though we set the velocity, it's not being read. That's because we update the velocity here, and we must set it statically. So let's go to the mouse where update velocity is ran. Yeah, there it is. So we set the velocity when really we should do direct accumulation. We should accumulate here. We should not set at all. And we should now do that. Okay, so we're falling. That's good. We want to fall. Now we need to stop falling. Is less than 0. No. Avatar height. There we go. And then okay. If this is only going to run gravity if the vehicle is up in the air, like if we jump. And when we move, we're going to induce a small amount of vertical offset and treat it as if we had jumped. It's a little way of being able to get over steps and bumps in the ground. So if we're on the ground, okay. Okay. Not falling. we're flying. Up. That's not correct. How is that possible? Oh, I see. So because the orientation, it's applied to the velocity. When we look up, we move up. Is there a way we can just detect? It seems to have... Now we're bouncing. Every time we look up a little bit, we bounce as we move. That's not good. Okay. Did something wrong? We just move backwards, fly into the air. Need a way of removing the Y component of the movement. So that sort of does it, but it's not really what I want. What I really want is the vertical pitch of the view to not be a component of the orientation used for the velocity. I want to be able to look down, but I don't want that to affect my movement. So perhaps do this.
In high school when you're still dumb, but like
Twice.
You just had the same password for everything?
yeah, it's not just that, but like
Let's find all the places where we use the orientation. Okay. Actually make it exclude pitch. The orientation there. There. Here. It needs to have the parameter there as documentation, but in this particular case, we're never going to be excluding pitch because this is the VR headset. Okay, and let's alternate this. All right, see if that worked. In fact, it did not. So I move. In fact, it's the exact opposite of work. Keeping me from moving into the ground. Still not moving. That's not correct. Oh, that's because I missed a step. I did things out of order. Update the velocity, then read the velocity, and orient it, then update the orientation correctly. No, I'm not moving at all. Because I'm not clicked on here. Okay. Okay, so we're moving. Alright, we're moving at the correct pace. We're not flying. There we go. We have a whole movement down. You can click on that, but it doesn't activate because it's not set up correctly. And click there. Good. We reset to the beginning and we zoom away. Unless we reset again. That is strange. Not zooming away. We will worry about that another time. For now, we have fixed the issue at hand. The fact that the pointers did not point correctly. So, with that in mind, I'm going to sign off now. We achieved our goal of fixing the pointer. And it's been almost an hour, so I'm not going to jump into another issue now. And I'm just gonna say goodbye. Thank you for watching. Once again, I'm Sean Macbeth. I'm the lead VR engineer at Notion Theory, and today we were working on Primrose Virtual Reality WebVR Framework. So check us out on Twitter, check us out online, and let us know what you think. Thank you.